Hello everyone, I am Baraa Hamdallah from Palestine, and I'm happy to share my journey and represent my final project for the Advanced Python course of Women in Tech program at Paper Airplanes. As a civil engineer specializing in environmental sciences, I joined the course because I wanted to enhance my data analytics skills, and I needed to gain in-depth knowledge and understanding of Python due to its simplicity, cross-platform functionality, and the extensive library support in solving simple to complicated challenges in the environmental and the geospatial analysis. It was certainly worth it because in the end, my journey was beyond advancement of my coding literacy, but a very interesting combination of inspiration because women participation was energetic and strong in the sense that each of us was contributing with a different input. The classes and the materials covered basic to advanced topics of Python combined with homework. The supervision was provided by professional, entire dedicated staff of tutors, mentors, and coordinators. My coding literacy was significantly enhanced, and now I can confidently state I'm able to solve challenges by integrated approaches and specialized libraries to address environmental challenges in my field. So basically, my project explores geospatial data and uses satellite images to extract environmental indices of vegetation, soil, and water. In a nutshell, the project will start by exploring and visualizing basic geographical data of Palestine, and then I'm taking a specified area of the Palestinian map, including the Dead Sea, to analyze, compute, and visualize the different indices of vegetation, soil, and water. And then in the end, I'm plotting a 3D model of the digital elevation model of the selected area. We start by highlighting the main points of the code, which are simply loading the data map of Palestine, plotting the data map of Palestine, and then I'm selecting some specific columns of the data. I am also loading a file containing population data from the Worldometer website. I'm also selecting some specific columns of the year, population, and city name. And in the end, I'm merging both files, the map of Palestine and the population file. Based on the city name, I'm selecting my city, Tulkarem, and I am plotting the distribution of the population in Tulkarem. Here are some outputs of the code represented by different dataset tables showing some of the Palestinian cities in both West Bank and Gaza Strip. And here you can see the occupied territories of Palestine represented by the West Bank and Gaza Strip. The second part is visualization and analysis of vegetation, soil, and water indices, which are truly important in the environmental management field. Here we're using the green band, the red band, and the near-infrared band of satellite images taken by Landsat 8. I also managed to create my own color map to enhance the differentiation between the indices. I am calculating the different indices using multiple functions, and then I am plotting them in figure size of 10 by 10. In the first map, you can see the green color representing healthy vegetation, the dark blue color or the mauve color is representing water bodies, and the sandy brown, dark brown color is representing less vegetation. The next one represents the water bodies. You can see the Dead Sea and part of the Mediterranean Sea represented by the bright blue colors. And also you can see here some small areas representing water bodies, and that was very interesting and yet accurate for me because usually when you use some commercial softwares, you have to do it in a complicated process to extract some accurate details on the maps. The last one represents the soil by the sandy dark brown colors, and the vegetation represents less soil areas, which might be some grass, some vegetation, or like different land covers containing less soil. The third one is the visualizing of the digital elevation model. And here I have used the rasterio, I have used the NumPy, and also I had to transform the pixel data to real data coordinates, geographical coordinates of X and Y, and then I have assigned the Z as the digital elevation model, and I have visualized the model in a 3D, showing a figure size of 10 by 7, and I had to, like, it was a challenge for me, this code, because I had to change some of the parameters to represent the 3D model in a realistic real-world model. You can see the color here representing the sea level. So the more bluish it is, the lower and below the sea level, which is the case for the Dead Sea area, since it's considered as the lowest point on land with an elevation of negative 400 meters or more than 400 meters. The other areas denoted in different colors representing mountain areas, land areas, but areas definitely above sea level. What are my next steps? Of course, I'm going to practice more Python and apply it wherever and whenever I can to solve any problem that comes on the way. Definitely more maps, more databases, and better applications to address different problems. It will also broaden my career scope and the pool of jobs that I can perform, since the Python is considered to be the prevalent requirement in the job market nowadays. Thank you all.